Hi, I'm Adolph Oliver, and this is a video clip about using systems of equations to solve what are often called value problems, but there's a wide range of things that fall into this. Anyway, it's often, instead of just using one variable problem, often easier to set up the equations using two or more variables. And then you can take that system that you get from that and solve it using either substitution or elimination. The value that we're talking about here doesn't always have to be a money unit. It can be other things like the number of people, for instance. Let's look at some examples here to give you an idea. Okay, here's our first example to look at. And let's read through it here. Jasmine and Shreya are selling pies for a school fundraiser. Customers can buy cherry pies and lemon meringue pies. Jasmine sold 13 cherry pies and 10 lemon meringue pies for a total of $228. Shreya sold 13 cherry pies and 1 lemon meringue pie for a total of $93. Find the cost of 1 cherry pie and 1 lemon pie. In other words, we want to find the cost of the individual pies. Well, the first thing you always want to do is decide on the variables that you're going to use. And how about if we do something like this? Let's just say C equals the cost, okay, of a cherry pie. Well, you know what I'm going to do for lemon. L equals the cost for cost of a lemon pie. Okay, you always want to set up your variables so anybody looking at the problem can see what you're doing and you can remember too. And this is also a great place for us to indicate the final answers. Now, let's translate the information we have. Jasmine sold 13 cherry pies and 10 lemon pies. So 13 cherries plus 10 lemons, okay, for a total of $228. Okay, now let's go back and double check this. Okay, 13 cherries, 10 lemons, 228. Okay, looks like I got that right. Okay, Shreya sold 13 cherries, okay, and 1 lemon, okay, for $93. Okay, now let's double check this one. You always want to make sure you get these original equations correct. 13 cherry plus 1 lemon for a total equals total of $93. Well, okay, look at this system here. The C's have the same coefficient. All I have to do is just take one of these and multiply by -1. So let's just take the first guy, and I can rewrite him underneath the second here, and multiply by -1, and the C's will go out. So here we go. -13C. I'm taking -1 times everybody upstairs here, and you have to make sure you do everybody all the way across. Minus 10L. I almost goofed that one up. Equals -228. Okay. Let's double check what we got here. Plus 13 became -13, plus 10 became -10, plus 228 became -228. Okay, we multiplied everybody by -1. Now notice the cherries go out as we decided here. And what do I have here? -9 lemons equals, well, let's see, what's the difference between this? I got 228 and 93. Okay. Looks like the difference is 135, and it's going to be minus. So minus 135. Okay. Divide both sides by -9 to solve for what the L is. And price is going to be positive, which it better be. So 135, and we're dividing that by 9, and we end up with 15. 15. So what this tells me is that the lemon pie okay, equals 15. Okay, well, let's take one of the equations, the one with the simpler numbers, looks like the second guy here, and let's work with him to solve for the cost of the cherry pies. So the original second equation was 13 cherries plus 1 lemon, which we know is 15, okay, equals 93. Well, we got to take this plus 15 and jump it over as negative 15. So I end up with 13 cherries equals, well, let's see, we got the 93, and we're subtracting 15 from it. So we end up with 78. Okay. Now, the next thing, of course, divide both sides by 13. Here we go. That cancels out here. Well, what's 78 divided by 13? Well, that comes out to be, let's see, 78 here. Get my calculator going here. 13, and looks like it's 6. Okay. So C equals 6. Okay. Well, going back up the top now, we can indicate everything. What's the cost of a cherry pie? Okay, this is all in dollars, so $6. What's the cost of a lemon pie? $15. Okay, well, there's our first example. Okay, here's another example, and as we read through this, you'll see that there's two things we're solving for, which is a good hint to use a 2x2 system to solve this. The State Fair is a popular field trip designation. This year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A rented and filled 8 vans and 10 buses with 506 students. High School B rented and filled 12 vans and 10 buses with 574 students. Each van and each bus carried the same number of students. Find the number of students in each van and each bus. Okay, well, there's two things. We want to find out how many students rode in a van and how many students rode in a bus. Well, V I'll take to be students, okay, in the van. And of course, you know I'm going to use B equals students, okay, in each of the buses. Okay, once again, we've got our variables identified. So anybody looking can see what we did, and a great place again to put the final answers here when we finish up. But now let's go back and get the information for the problem. The senior class at High School A rented and filled 8 vans and 10 buses. So 8 vans plus 10 buses equaled, and how many total people did we have? 506. Okay. Now, High School B rented and filled 12 vans and 10 buses. 12 vans plus 10 buses. Okay. And with a total of 574 students. Let's double check both of these. Senior class at High School A rented and filled 8 vans, 10 buses, 506 students. 8 vans, 10 buses, 506. Okay, that's good. High School B rented and filled 12 vans and 10 buses, 574. 12 vans, 10 buses, 574. Well, look at this. We got another gift. Real easy to eliminate the B's here. All I have to do is, let's say I take the first equation here and multiply it by -1. So -1 times 8 will be -8v. -1 times plus 10b will -10b. And -1 times 506, negative 506. Okay, so now here we go. Notice, of course, it was real easy to eliminate the buses. We did that. What do we got here? 4 vans equals, and let's see, 74 minus 6 positive wins here. It'd be positive 68. Okay, well now, we know what we're going to do here. We're going to do a division. Take and divide both sides by 4 here to get V. And let's see, 4 goes into 68. I just did it on my calculator. Comes out to be 17. So a van equals 17. Okay, let's see what a bus has. Either one of the equations up here will work. Let's do the second guy. 8 vans, which would be 8 times 17, plus 10 buses equals 506. Well, okay, 8 times 17 is going to give me a total of 136 students. So this is 136, okay, plus 10 times B equals 506. Well, take and move the 136 over as negative 136, and I've got now 10B equals, well, the 506, and we're subtracting from that 136. Okay, that comes out to be 370. Okay, so now we simply divide both sides by 10, and we get the buses equal to, looks like it's 37. Okay, here we go. So there it is. By using 2 variables, we were able to set up our system of equations, solving for V and B. Students in a van equals 17 students, and students in a bus equals 37 students. Okay, here's another example. Paul and Nibia each improved their yards by planting daylilies and ornamental grass. So we're looking at 2 things again here. They bought their supplies from the same store. Paul spent $72 on 4 daylilies and 5 bunches of ornamental grass. Nibia spent $136, I should say, on 6 daylilies and 11 bunches of ornamental grass. Find the cost of each daylily and each bunch of ornamental grass. Okay, well, let's use day, D, for cost of the daylilies. Okay, and well, let's see, what can we use for the grass? Let's just use G for grass. Cost of grass bunches. Okay, once again, you can pick any variables you want, but it's good to pick variables that remind you what they stand for. And so now let's go back and get our information. Paul spent $72, okay? 4 daylilies and 5 bunches of grass. So 4 daylilies plus 5 bunches of grass cost him, what was it again here? $72. Okay. Now, Nibia, let's see, spent 136, 6 daylilies and 11 bunches of grass. So 6 daylilies plus 11 bunches of grass equaled, and what did we have here? $136. Okay, let's double check these guys. 4 daylilies and 5 bunches of grass, $72. Okay, looks good. 6 daylilies and 11 bunches of grass equals 136. 6 days, 11 bunches. Okay, we look good. Okay, now here we go. We want to eliminate one of the variables here. The LCM for the daylilies, the first lowest number they'd hit would be 12. Over here it'd be 55 for the bunch grasses. So we're going to go after the daylilies here. And so remember, the LCM equals 12. That's the lowest multiple they'll both hit. So we've got to doctor up both of these. So let's say I take the first equation. I want to change the daylilies to 12. Got to multiply by 3. So here we go. 3 times 4 is 12 daylilies, plus 3 times 5 is 15 bunches of grass equals, let's see, 3 times 7 is 21, and 216. Now let's double check this. 3 times 4 is 12, 3 times 5 is 15, 3 times 72, 216. Okay, that looks good. Now, we got to take the second equation here and change the daylilies to minus 12. Okay, and so we got to multiply by negative 2. So I end up with negative 12D minus 22G equals, let's see, that'd be 272, but it's going to be minus 272. Okay, let's see what we got here again. Negative 2 times 6 is negative 12. Negative 2 times 11, negative 22. 2 times 136 would be 272, but it's going to be minus. So yeah, here we go. Now, we canceled out the daylilies. So let's see, what do we have? Plus 15 bunches of grass minus 22 of them. So negative wins by 7. Negative 7 bunches of grass. And let's see what we have here. 272. Okay, and we want the difference with 216. Okay, turns out to be 56. Okay, and of course minus wins here. Okay, divide both sides by negative 7 here. Okay, divide by negative 7 here. And we get G equals positive, let's see, I think this just goes into 8. So G equals 8. Okay, let's go back and find what the daylilies were. I'll just take the first equation up here. That looks like it has the simpler numbers. Okay, and so let's write it down here. 4 times D, that's what we're solving for, so I leave the D in, plus 5 times the bunch grass, which is $8, as we just found, equals 72. Okay, this is 4D plus 40 equals 72. And let's keep going on this. Take the plus 40, go over as minus 40. So I get 4D equals, looks like it's 32. Divide both sides by 4. Looks like D, when you reduce this, equals 8 also. Okay, so it turns out that the bunches of grass and the daylilies here in this problem are the same cost. Now we can go back and put those back up on top then here. What's the cost of one of the daylily bunches? $8. What's the cost of a grass bunch? Also $8. Okay, well, once again, what gave this away as a good problem to use our system on was that we were solving for 2 different things here. And if we used 2 different variables, it was easy to set up the equations. Then we just used our elimination methods to solve, and we came up with the answer.